Hello guys, I think we're now live. I'm just going to check whether the UI works properly, whether we are good, whether you guys can all hear me. We're doing this with a slightly different streaming technology, so I'm not really sure whether you guys can hear me, whether the session is on live, the rest of it. So I'm going to keep speaking for say half a minute, 1 minute, 2 minutes, 3 minutes. So if nobody pings me, then I'll assume whatever we're doing is right. But it's just the software is live in 2 minutes, but we should have been live. So I'm just a little worried already. So I'm going to wait to get some form of confirmation. If no comments come that things are not working, then I'm going to continue and do this. Super, wonderful. We are live and we're good to go. Somebody's given me the green signal. We're doing a session where we've got a bunch of queries from our students. We'll clear this out. And then if need be, we'll go to the comment section and see the questions that are there and then clear those out as well. And so we're going to do this as a doubt clarification session for 2 IM students and focusing on quant. So we're going to focus on a bunch of things that a lot of students might likely have faced, clear them out. We'll also take a couple of detours to say how we can take value from the course, what you can do, where we are there to help, how we can chip in, what more you would want us to do, the rest of it. Wonderful. I'm going to jump in and solve. If the highest power of 225 in n factorial is 10, find the number of values that n can assume. I mean, we're used to solving the question what n is, but what if this is the reverse of it? Wonderful. So the question is beautiful. So what is the highest power of 5 in 258 factorial? We can do that. What is the highest power of 10 in 197 factorial? We can do that. Right? Highest power of 10 in a number, 10 is 2 into 5. So highest power of 10 in a factorial, we have to find highest power of 2 and highest power of 5. We don't have to worry about 2, we just have to worry about 5. So this question is pretty much a trial and error question based on the method that we know. So what is the highest power of n that divides n factorial? This is n by 5 plus integer part of n by 25 plus integer part of n by 125. Successive division by 5. Right? So highest power of 225. 225 is 3 square into 5 square. 3 square into 5 square power 10 sits inside n factorial. In n factorial, 3 power 20 into 5 power 20 sits. If 5 power 20 sits inside n factorial, then 3 power 20 definitely sits inside n factorial. So this question is effectively find the number of values of n that are multiples of 5 power 20. And wonderful, that's what this is, but not the highest power of 225 in n factorial is 10. Then we need to find the number of values of n. Let's find the smallest value of n. That's a multiple of 5 power 20, and then we'll build from there. And so this is trial and error. We are going to find integer part of n by 5 and then divide that by 5 and so on. If we did 100 by 5, that's 20. And so if n were 100, then 100 divided by 5 is 20 plus 20 by 5, which is 4. This is 24. 5 power 24 will divide 100 factorial, so it's not 100. Right? So let's try maybe 90. 90 by 5 is 18. 18 by 5 is 3. This is 21. 90 factorial is a multiple of 5 power 21. But we want the number of values n can assume. We are looking to find the smallest value. Right? So if we are looking for 5 power 20, 90 factorial. Sorry about that. 90 factorial is a multiple of 5 power 21. So 85 factorial will be a multiple of 5 power 20. So if n were 85, this works. We have 5 power 20 sitting inside that. That means it's a multiple of 225 power 10. Obviously 86 will work, 87 will work, 88 will work, 89 will work. These 5 values will work. Now the beauty of it is 90 will work, 91 will work, 92, 93, 94. These will also work because the moment we go to 90, we get to 5 power 21, but 5 power 21 is not the same as 225 per 11. To get to 225 per 11, we need 5 per 22. That happens only with 95. Fine. So this is just trial and error, nothing more than that. We need to understand this question clearly. This is 3 square into 5 square. So we're looking at 5 power 20 sitting inside n factorial. We'll find the smallest n such that 5 power 20 sits inside that. And then we go step by step. We can even take in 5 power 21, but we'll stop short of 5 power 22. 95 factorial has 5 power 22 units. So 85 to 94, 10 values will work. Fine, so this is trial and error, but we'll be a little scientific about trial and error. We start with 100, then go to 95, then go to 90, then jump to 85, and then we know that 85 works, then go step by step after that. We mix this up, questions where we are solving something and where we are discussing something. I'm clear with contents of number theory and geometry. I find it difficult to solve them in mocks. This happens usually. Number theory and geometry are particularly topics which are learnt iteratively. Fine. So you learn geometry once. The first round, you still learn fundas. When you go to round 2, you'll be able to understand everything that's being solved. But the key point will be, you probably won't know why that particular method was chosen. So I see this, I see the solution, and the solution beautifully explains why similarity was used. And I follow the solution 100%. I understand the entirety of the solution. But then the next question, I don't know what the starting point is. And I don't know why in some question the guy who's solving uses similarity, in some question they use congruent, in some question they use tangent secant theorem. Right? So then in round 3, you get better at this. After doing a bunch of questions, we go to kind of round 3, where you say, I'm going to place markers in my mind. Every time I see a secant, I'll say tangent secant theorem. Every time I see angle bisector, I'll talk about angle bisector theorem. Every time I see an incircle, I tell myself area of triangle is R into S. Every time I see circumcircle, I say area is ABC by 4R. When I see a right angle triangle, I know circumradius is H by 2. I know in radius is A plus B minus H by 2. I might forget this, but I need to keep this in mind. So you place a bunch of markers in your mind saying, okay, I seem to be forgetting this. In these type of questions, this is my keyword. The moment I see a secant, I'm going to say, okay, there's a secant sitting there. Am I going to use tangent secant theorem somewhere? And I'm having to establish, it looks like I'm having to prove something before I go further. I have to use congruence or similarity. Fine, so you have to place those markers in your mind slowly. The markers will register only when you've done lots of questions, where you understand the solution completely, accept the fact and be okay with the fact that maybe you didn't get it, but the solutions are understandable. Then crack them and come through. Then do one more round. And once you've done this, once you've placed the markers, then you get better and better at this. When you cannot straight away start doing, okay, this question congruent, this question similarity, before having done a bunch of questions. The same idea works for number theory. Why are they using one way of thinking about HCF and LCM in one approach? Why is suddenly some other theorem being used? Why is some other test of divisibility being used? Once I know what method to use, the solution becomes simple. But for the life of me, I cannot figure out what method to use. That's where a great many of us are. That happens in round 2, round 3, where you say, we put a marker and say, this is what I will do. When you're picking a route and you've gone through that once, but you keep missing that, you say, moment I see Johnson's Bakery, I'll take a right. So you're on the road looking for Johnson's Bakery. So you have to say, moment I see secant, I need to think about tangent secant theorem. And that happens in round 3. So do that. It should become easier. These topics are learned iteratively, but once you have put those 3-4 iterations, these questions become joyful. You'll have fun handling these questions. Installments concept. Fine. So installments, very, very simple idea. Don't do a formulaic thing. Fine. First thing, don't go for the formulaic approach. It's not required. Fine. Installment as a notion works only when there is compound interest. There's no such thing as simple interest in installments. So don't complicate it. Right? So suppose I borrow 20,000 with a rate of interest of 10%. and I pay in 2 equal installments over 2 years. And so this 20,000, imagine this becoming something at the end of year 1 and becoming something at the end of year 2. If you are not paying any installment, you're paying at the end of the second year, then this becomes 20,000 into 1.1, 10% interest, and then this is 20,000 into 1.1 into 1.1, 1.1 whole square. Now how would we do this? We think of it as 2 years separately, not compounding. We basically say this is one borrowing and repayment, this is one borrowing and repayment. So what do I say? 20,000 I have borrowed, it becomes 20,000 into 1.1, I repay X. 20,000 into 1.1 is 22,000. I have repaid X. The amount outstanding has become 22,000. I have repaid X, or it's like saying at the beginning of year, at the end of year 1, beginning of year 2, I am borrowing 22,000 minus X. Therefore, I'll end up paying 22,000 minus X into 1.1. What our question is telling us that this number and this number are equal. So X equals 22,000 minus X into 1.1. If there were 3 years, 4 years, 5 years, the same approach would work. You pay off and then you say, okay, there is a lesser to do, lesser to solve, lesser outstanding principal, and then we take that and we simplify, then we solve that. Right? So very simple idea, wonderful idea. Every time you say, I'm going to think of this as borrowing for first year, borrowing for the second year, borrowing for the third year, and so on. If your repayment is in AP, GP, one is 2,000 more than the other, one is 3,000 less than the other, all of that, the approach is same. Borrow for the first year, but you're not paying off the whole thing. So there is some outstanding amount. Think of it as, this is what I'm borrowing at the beginning of the next year. And then there's some outstanding amount. So AP, GP, anything can be constructed. If you just imagine this borrowing problem as a series of 1 year problems. That's all we need to do. Concepts on a circular track moving continuously to and fro in a straight line, the respective meeting points. Circular track, always think in terms of relative speed. Fine. So if your speed is A and another speed is B, if you're moving in the same direction, relative speed is A minus B. Opposite direction, relative speed is A plus B. If you're starting at the same point, you will meet after you have gained an entire lap. Fine. So imagine this, those of you who follow racing, you can imagine this. You have this notion of lapped out. So if the guy right at the peak, at the top, laps out the guy right at the end, at the middle of the 34th lap, that means when the faster guy is in the middle of the 35th lap, the slower guy is in the middle of the 34th lap. He has gained one full lap. Fine. So lap length by relative speed gives you meeting point. Then every subsequent meeting point, meeting at the beginning, meeting at the middle, meeting at the halfway point, all of those you can figure out after that. Lap length is the distance you should gain by meeting point, by relative speed, the time it will take for you to gain that. Once you have done this, everything else falls in place after that. Fine. So, and then you say, suppose you say they meet for the first time after 104 seconds. Second time will happen after 208 seconds. Into 3, into 4, into 5. When will they meet at the starting point? That starting point should be a multiple of the time, lap time and this 104. Take an LCM and then you figure that out. Fine. For moving continuously to and fro in a straight line, it is not formulaic. Mainly because when they are moving, when suppose the question says P and Q, P goes like this, Q goes like this, then initially when they start off, P and Q will be moving in opposite direction, relative speed works. After that, P will be going like this, Q will be going like this. Then after P reaches, right, Q might not yet have reached. So P will be catching up with Q. So if you're having intermediary points, at some time they're traveling in opposite direction, sometime they're traveling in the same direction. So it's better to do it step by step. Right? It is possible to imagine this as Q going here and coming back. So P is effectively still only traveling in the, it's imagining this like going around an oval path like that. But that sometimes breaks down. It is far better to do step by step if you're going toward flow. So the quicker one will reach first. So reach that point. After that, the quicker one will be catching up with the slower one. That's okay. Maybe the slower one will reach before they catch up. That's fine. And then they'll both be moving in opposite directions. Follow that. So sometimes it is helpful to reimagine. It is possible to reimagine. That is tricky. My preference is to always go step by step methodically. This is a question, so I'm not going to rush this. So try to give it a go. I'm going to give you some time. Try this question, then we'll solve this. To start with, from an exam point of view, this is an incredibly tough question. So cube root of 14 minus a plus cube root of 14 plus a equals 4. And so if I were dealing with this question, then I would go straight for a trial and error approach, try to guess the answer, nothing more than that. Because this algebraically solving this is impossibly tough. Cubing both sides, squaring both sides, trying to factorize, all of those just don't work. It becomes a very tough question. If I were worried about multiple answers, then I will stay away from this. I will stay far away from this. And so the one answer that works is 14 minus 13, 14 plus 13. This is cube root of 27, 3, cube root of 1, 1 plus 3. So a equals 13 works. A equals minus 13 will also work. This becomes 14 minus 13, 14 plus minus 13. They work. And so that is one possibility which I know that will solve our problem, will get us going. And my gut feel is others don't work. So if I have a nice choice with this 13 into minus 13, I'm marking that. But otherwise, I'm not looking to solve this question because this is a properly tough question. If somebody has a very intuitive way of solving this, please stick it in the comment. I would love to learn that approach, but otherwise this is properly tough. It's unlikely that we'll get questions this tough. Try this. This, however, is doable. Give this a go. This is a wonderful question. There are a couple of approaches here. First, I'm going to take the broad-based approach. Fine. So, whenever you have a polynomial, the largest power dominates, especially as you go to higher and higher values. What do I mean by that? N cube is positive. Right. So, this means if you, notwithstanding what numbers are here, If we go to larger numbers, after a point of time, my graph is going to go higher and higher. If I manage to draw a graph of this, maybe after 10 or 11 or 100 or whatever, my top power will dominate. The value of n cube will be so much higher than the value of n square or n that this will effectively be based on what n cube is and not what n square and n are. Right? So that point of it being utterly dominant will happen at a reasonably small value. So what I will do, if I'm not taking an algebraic approach, I would plug in n equal to 10 and see if it works. N equal to 10, this is 1000 minus 110 plus 320 minus 28. 10 works. And 10 works. Now I know straight away 11 will work, 12 will work. This number is going to go higher, quicker than these numbers are going to go higher. So, sorry, 11 into 10 square, 1100 plus 320 minus 28. This is minus 100, but this works. Straight away I know that 10 works, and 10 works wonderfully well. 10,000 minus 1100 plus 320 minus 28. 11, 12, 13, everything works after that, because I know that this number, this will go faster, higher. This will grow quicker than these. And so let's try 9. 9 cube is 729 minus 11 into 81 plus 32 into 9 minus 28. 11 into 81, 11 ones are 11, 88 plus 1, 89, 899, 729 minus 891 plus 32 into 9 is 288 minus 28. So negative something, this is more positive, 9 also works. Fine. Let me jump down and try a 6. 6 cube is 216 minus 11 into 36 plus 32 into 6 minus 28. 11 into 36 is 360 plus 36, 396. 32 into 6 is 192 minus 28, 216. 216 plus 192 is 8. 1 plus 9, 10, 0, 1. 3 plus 1, 4, 408 minus 396 plus 28 is 424. 6 is negative, 6 doesn't work. Right, so 10, 11, 12, 13, all of them work. 9 or 10 works, 6 makes it negative. Fine, so 6 doesn't work. Fine, so 10 and 9 work, 6 doesn't work. Fine, so I could, the inequality, we want the smallest integer where it works, so it's 7 or 8. I'm just going to substitute 7 or 8. I'll substitute 7 if it works, 7 is my answer. If 7 doesn't work, 8 is my answer. Then 7 cube is 343 plus 32 into 7 is 224. 11 into 7 square, 49 into 11, 490 plus 49, 539 and 28. And so this is 7, 6, 5, 7, 6, 5. So 7 makes it 0. So 7 doesn't work. 8 will work. So the smallest integer that works is 8. Trial and error works. Start with the utterly dominant, find one value, juggle around that, and then you're through. The other approach is to see if we can figure out a root. N cube minus 11n square plus 32n minus 28. 1 minus 11 plus 32 minus 28 doesn't work. 1 doesn't work. 2 makes it 8 minus 44 plus 64 minus 28. 72, 72, 2 works. So 2 satisfies this, or n minus 2 is a factor of this. N minus 2 is a factor. Divide this by n minus 2. Remaining will be a quadratic. Factorize that. We know the whole thing. Then we can find the smallest equation. N minus 7 is a factor, but that we figured out the tougher way. Key point here, the largest power will dominate. Start from there. Work from there. How to find if a big number is a prime number? There's no great method for this. There's no scientific method for this. Test of divisibility till square root is the time tested method. 4000, the square root of 4000 is somewhere around 65. 65 square is 4225. 64 square is 4096, I think, somewhere there. So the brute force method, try 2, 3, 5, 7, 11, 13, 17, 19, and then somewhere it works. There is no banker shortcut for finding prime numbers. There's not been. That's why prime numbers are so fascinating. There's no banker way to generate prime numbers. There's no way to establish that a number is prime. No way to find subsequent primes, twin primes, none of that. Right. Is LCM into HCF equal to product of numbers applicable only for two numbers? Definitely yes. Definitely yes. So think about this. So if you have two numbers, 8 and 24. HCF is 8, LCM is 24. If you add a third number, say 32, HCF will continue to be 8. Product of these three numbers, 8 into 24 into 32. HCF is 8, LCM is 32, and then accommodating a 3, 96. 8 into 96 is not product of these three numbers. And so HCF, LCM into HCF equal to product of two numbers only for two numbers. It does not, need not hold good for 3 or 4 numbers. That is the limitation. Product of two numbers is equal to product of HCF and LCM. Fine. So that is a clear limitation. If there are two numbers, and so 6 into 24, 6 is HCF, 24 is LCM, is 144. This does not mean product of any two numbers adding up to 144 can have HCF and LCM as 6 and 4. That's not possible. And so if you're told that product of two numbers versus 144, then any two numbers that multiply to give 144 cannot be HCF and LCM. Product of two numbers is 144. HCF and LCM could be 4 and 36. That is possible. It can be 2 and 72. It's possible. But it cannot be 9 and 16. So you cannot, these are possible. This is not possible. And so that is a limitation there. Product of HCF and LCM is product of two numbers, not more than that. Factorials of a slightly larger number, not that I know of. You have to multiply and find out. You can find the largest power of a prime that divides it, largest prime of a composite number that divides it. All of those we can do, but we cannot find a factorial. Once it becomes a large number, we are in trouble. We have to multiply and get to bigger and bigger numbers. There's no fascination in finding 70 factorial or 80 factorial. It's so large that it holds no significance. The question will be, what is the largest power of something that divides 80 factorial? What is the number with exactly 3 factors that divides 80 factorial? Some variant like that, but not in actually finding the number. This is very good. Give you some time to think about it. Give it a go. I'm going to do this by two methods. One is a boring, more algebraic method. And so if you have 1 plus x the whole power n, this can be written as nc0 plus nc1 into x power 1 plus nc2 into x square all the way till ncn into x power n. Or the other variant, you can write it as nc0 x power n, nc1 x power n minus 1 and so on. The binomial expansion part of it. Here if you put 1 plus x whole power 9, so it's 9c0 plus 9c1 into x power 1 plus 9c2 into x square and so on. And then you put x equal to 1, this is 2 power 9, that is sum of all powers. And that is the one way of establishing it using binomial theorem. The other way is more interesting. Suppose you have a set which has numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, or you have 9 objects inside a box and you want to pick some from it. You want to create a subset out of this. How will you think about it? You can say, in my subset, I can either have 1 or not have 1. I can either have 2 or not have 2, have 3 or not have 3. So each of these can either be in or out. 2 states for each number. The number of subsets is 2 power 9, including a null set where nothing is included, and the set itself where everything is included. The other way of thinking about this, I can have a subset which has only one element. Number of ways of selecting that, 9C1. 2 elements, 9C2, 9C3, 9C9, and no elements. So the number of subsets, if you add all of this, that should be the same as this. That's the other way of thinking about it. Right? Or you can say, I toss a coin 9 times. Total number of outcomes is 2 power 9. I could have 0 heads, 1 head, 2 heads, 3 heads, all the way till 9 heads. Each of these outcomes should add up to that 2 power 9. That's how it reconciles. And then you're good. It's another way of reimagining the two numericals that we have. How to tackle these kinds of questions? Fine, just give it a read. We'll discuss this. Wonderful. I hope you've read the question. This method out here is reasonable. I'm not sure about the question that much. I'll tell you why. The key thing here is to imagine these numbers as wonderful fractions. 60% of a number A, that is 3 by 5A, is added to B to give 7 by 4B. The key point is to be able to write 60% as 3 by 5 and 175% as 7 by 4. Then you're through. Then which of the following is true regarding the values of A and B? Right? So we finally get the ratio. A by B is 5:4. Right? So how do we interpret this? This depends on whether we're allowed to have A and B as only positive or non-negative or all real numbers. Minus 10 and minus 8 are in the ratio 5:4. So are 10 and 8. The question is restrictive. It says positive. Then if two numbers are in the ratio 5:4, A is greater than B. Done. But if that is not the case, if we cannot say that for sure, then you're answering this. Talking about non-negative, then you're worried about this is also possible. So we'll have to worry about it. Where negatives come in, we have to worry about that. But generally these kind of questions make it clear in the exam that you're dealing with only positive numbers or some categorization like that. If that is given, if A is to B is 5:4 and you're living in the positive real number world, then you can say A is greater than B. Under which topics specifically will we learn about differentiation, maxima and minima? And so in the 2IIM course, and no topic will we learn differentiation. Differentiation is not required. I've taken CAT 9 times. I've never used differentiation in the exam. And so the alternate for differentiation is this wonderful method called the idea of completion of squares. It's a good method to learn that gets used extensively across the board. We discussed this method in inequalities, in functions, in coordinate geometry. So across the board, there's a question in profit and loss where we use this method. I like the idea of this approach. So I've made sure that this is present in at least 3 places inside the course. So as a thumb rule, if you're dealing with maximum this or minimum that, you're going to deal with a quadratic equation in some form. You complete the square and reimagine that quadratic, then you're good. You can solve and approach any of these questions. So you're looking to approach something like that, where you're thinking about completing the square and approaching that. Differentiation is not required. There's an exam designed for commerce graduates and lawyers and doctors. So the expectation is not that someone should know differentiation. Sometimes differentiation does make life easier, but having differentiation in your toolkit is like taking a big bazooka to a street fight. It's obviously useful, but if you have that, your temptation is to use it willy-nilly. And there's some nuance that you might overlook and get it wrong. Unless you're very comfortable with differentiation, don't use differentiation. If you don't know differentiation, don't bother learning differentiation. You don't need this for this exam. Differentiation does make some questions simpler, no doubt about it, but it's not a must-have. Sometimes it overcomplicates things. It is better to stay away from it. I've completed all LOD 1 questions. Should I only focus on mocks now, or should I go through LOD 2 and 3? Generally, if you've done LOD 1, you're ready. Go for mocks. Mocks have the best questions. So if your basic level of comfort is set in any topic, in a bunch of topics, you're mock ready. And so I'm going to take a detour and talk about how to prepare. What is the sequence of preparing using the 2IM content when you all are used to our framework. So start with the online lesson. That's the best starting point because it goes through the fundamentals in very structured, methodical way. En route, cover checkpoint quizzes. If you're ready for it, just cover prep edge as well. And so there are 3 phases to learning, the way we look at it. One is funda, part 2 is drill, part 3 is getting game ready. This is CAT ready. Funda is the learning part, the online class itself. Drill is checkpoint quiz. CAT ready is prep edge quiz. Right? Sometimes you are very clear about the fundamentals. You feel like you've learned that well, but you don't have processes automated. You're not natural at that. You're not happily solving quadratic equations. You still are doing it very consciously. And they talk about multiple stages of learning. So the best parallel I usually like saying is when you're learning to drive a car or learning to ride a bike. When you're learning it, you have to be very careful and conscious about the gear and clutch and accelerator mechanism. Your mind is processing every little bit. If you want to go from gear 1 to gear 2, then your mind accounts for the fact that you have to hold the clutch, change the gear, release the clutch, and plan everything. You're operationally doing everything. Fine. So, and your mind is occupied with this, which is why you drive 5-6 kilometers, you're dead tired. It's daunting to imagine that people drive 20 kilometers to office every day. When I learned driving, I would be flat out tired in 6 kilometers. I'll be like, if I had to do this and take car to office, I can only take my car to office and come back. I cannot work. I'm too tired. Right? But sooner or later, your muscle memory kicks in. You start doing your hand movements and your leg movements more naturally. And then you can wander, look at the board here and the sign there and the street symbol there and the good-looking person in the next car, all of that. Right? So, and that happens because you've automated processes. That is where this comes in. Now you're comfortable with all basic processes. You know all the fundamentals. You're ready to travel to the slightly trickier, tougher territory. Not routine, but something you have to figure out. It's like traveling to another place with a GPS. So one eye is on the GPS, one eye is in the road and traffic. You're on a new road, but you can still navigate that because you're comfortable with the basic ideas. That's how this learning process is going to be. So it's always good to start with the online video. Checkpoint quiz is the level of the drill. Prep edge quiz is like this. The study material that you have revisits this and gives practice for this. It's an overlap of these two. So there's a bunch of questions with solved examples, exercises, and practice questions. So you revisit fundamentals, learn some bit, and practice some bit. There are a few tougher questions also thrown in because you need to get ready. And the section test, topic-wise test are here. Adding an entire test engine to focus predominantly on this. It will be up and live in about maximum 8 to 10 days. That is going to be focusing completely on this. So you will be game ready and focusing on question after question after question here. The speed test book, it straddles these two worlds. There are a bunch of questions that are routine and you just knock it off and solve. Bunch that are slightly tougher based on previous year CAT papers. So it is between these two. So how should you prepare? You should be able to be in a position where you identify your gaps. If fundamentals, don't skip fundamentals, learn that. The spending 45 minutes or an hour and a half or two on learning, going through the script is very useful. I would go to the extent of saying, take the class, finish the checkpoint quiz, finish the prep edge quiz, get a sense of what the topic is, what the fundas are, what the drill is, what CAT level is. So that now you know in your mind what question is impossibly tough and what is too easy for CAT. So you know what the LODs mean. Right? And then if you feel like you need to reinforce fundamentals, go through the study material, the theory again, solved examples, illustrative exercises, exercise question, the whole thing. But if you feel like, look, I know the funda, then what more is there in ratio and proportion? I want to just practice. Then go to the speed test book, practice it. Suppose you feel like, look, I've done this. I've taken CAT before. I want to learn the funda. I've learned that. But I can naturally solve questions on quadratic equations. I'm not worried. I don't want to do 45 very simple questions. I already know this. Then jump to CAT level questions, benchmark yourself, peg yourself to see if you can step up for the level of difficulty. Sometimes you think you're ready and then you get your backside handed to you in tough questions. Come back and do more drill. If you're having a gap at the concept level, revisit fundamentals. If you're having a gap at the speed level, revisit drill. So it is iterative. It's not one mechanism. So sometimes you lose steam in doing 100 simple questions. You're ready. So suppose you start a speed test book, you do 20 questions, and you feel like, look, I'm not pushing myself. I can knock all this off, but I want to know whether I can push myself. Stop that and go to the CAT level questions. Hit either the question back or hit the test engine. It's going to be there in a week. So the method is funda, drill, CAT level. Funda, get comfortable, automate processes, step up for one level of difficulty. If your fundas are very clear and you're reasonably quick in very basic stuff, challenge yourself with tougher questions. If you feel like you need to automate processes and get it done, then do a lot of practice questions before you push yourself to the next level. Iterate in that. The thing you'll have to learn where if getting stuff right is a problem, then fundamentals are weak. If doing quickly is a problem, then you have not automated enough. Based on that, go either to reinforce this or to reinforce this. If speed is the problem, then drill. If getting stuff right, if accuracy is the problem, if you're not able to approach, you're getting things wrong, then hit fundamentals. Script wise, hit fundamentals, do the drill, step up for CAT level. Where you jump off and go to the next one is up to you. You'll get fine-tuned slowly. If you're doing it for the first time, do the entire class. That is where we put all three in one place. You learn, you do checkpoint quiz, you do prep edge quiz. If you have learned ratios like that, then you will have a sense of what ratios are about, what kind of questions you can expect in the exam, what kind of questions are for practice, what is the underlying idea for each concept. And then you feel like, look, now I have a handle on this. You might sense that it's an easy topic, I'm just going to jump to CAT level and nail this. Or I need a lot more practice because it's a fundamental topic, let me do a lot more drill. That decision you take based on where you are in for each topic. LOD is level of difficulty. I see a comment somewhere. I'm able to solve a lot of questions from a particular topic, but then the questions that I'm not able to solve scare me. You and me both. So I see a CAT paper and then I see a mock and a bunch of questions. There are about 10% that or 20% that I don't know how to approach. Sometimes I'm confident that the question is too difficult. It's not this level. Sometimes I feel that maybe I'm missing something. And so it's going to happen. With more and more practice, you'll get better. Seeing the solutions will give you confidence. Sometimes you see the solution for a question and then you say, this is too wacky for a CAT. These guys have just gotten it wrong. This level of difficulty, they are never going to test. Or, look, I will never be able to do this, so I don't worry. And so, iterating and practicing and revisiting will help. In terms of fear, you need to kind of sometimes put yourself in a bubble and shut yourself off this continuous random feedback mechanism. So every question that you're not able to solve, cannot throw you off your game. You can be apprehensive. You can feel like maybe I'm not on top of this. Maybe I'll check out the solutions and I'll get better. But you cannot you cannot crumble under the pressure of every single question that you miss out. This paper is about being good at what you're good at and not really worrying about what you're bad at. And the best example that I love giving is like you're in a chase situation. There are candidates who are like Virat Kohli as a batsman. There are candidates who are like Dhoni. Virat Kohli can score off your best bowler, your worst bowler, can nurdle singles, can step it up. He has the skill set to handle everything. Whereas Dhoni has to plan. What he lacks in skill, he has to compensate with savviness. But sometimes the Dhoni manages to outperform the Kohli because Kohli will want to hit the fastest bowler, their prime bowler, for a 4 every over. Push himself, do something and get it wrong. Whereas Dhoni will play off an over for only 3 runs in the 44th over and tonk the 5th bowler for 18 and take you home. Fine. So the thing, whenever what you can't solve won't hurt you. Knowing what you can solve and not solve, that is the critical thing. And I've known lots of guys who have very clear weaknesses but nail this exam because they very clearly know what their very clear weaknesses are. Fine. So if I hate trigonometry, it's an easy decision. I won't touch it. I don't understand sine, cos, tan. Fine. So if it is very clear that a question is dicey, then you should be like, look, this I don't get. I'll leave this. I'll go hide. I'll go park myself in what I'm strong at. Fine. So every time you have to leave a question on something that is way out of your league, then you should say, look, I have 20 more questions to nail this section. I don't need that. The gray area is what can hurt you. So wherever there is a question that you don't get, you basically have to tell yourself, I'm becoming savvier. I'm becoming smarter about this paper. I know I don't get it. I can leave it alone. That's what you need to tell yourself. Fine. And learn to know whether it was an easy question that you missed some funda on, or it's actually a really tough question. So there's a learning aspect which you have to revisit and learn. But from an exam aspect, not knowing a bunch of questions, that shouldn't intimidate you. Forget about it. You can know only 70% of the syllabus and go to Ahmedabad, Bangalore, Calcutta. I know plenty of guys who have done that, plenty of guys who do it year after year after year. I've seen the counter example also. I've seen doyens of number theory and geometry not go in because on the day they'll get stuck in one number theory question and they will just not be able to leave it, grapple with it like as if it were an Olympiad question and waste 7 minutes in the process and start sweating bricks at the end of it and crumble under the pressure. The savvy ones always get away. You have to find a way of maximizing those 3 hours. You're not here to prove anything to anybody. So keep that in mind. If you're very clear that something is too tough, have a smile on your face, find something that you can nail. Very interesting question. I really liked it. Here, percentage of water has been, the question says pure milk costs 10 per liter. A milkman wants to make a profit of 20% by selling adulterated milk at the same price. What percentage of water should he add? The actual solving part in this question is not what the questioner has asked. And he's not said, how do we solve this? He said, I find that 200 ml of water has to be added to 1 liter of milk. Fine. So the question is saying, what percentage of water should he add? Am I thinking of water percentage as 200 ml by 1200 ml or 200 by 1000? And so the key phrase here to me is what percentage of water should he add? So you have something, to that you add something. I want this as a percentage of what I had originally. Fine. If the question were what percentage of the mixture would be water, then I'm thinking about 200 by 1200. Fine. So there's a difference here. What should I add? To India's GDP, this is being added. What is the percentage growth? Percentage growth is change by initial quantity into 100. My speed increases. My mock cat score increases. It increases by what percentage? Whatever is increased by, divided by what it was originally. So what percentage should he add? What is he adding to? That's my reference point. What percentage of the mixture is water? Then I have to think about overall volume. Is it the right approach to first go through all the videos properly, then go the reference material, finally through speed test? We've already covered this. The learning class is one aspect. This contains checkpoint quiz and prep page. The class is built in a way as to showcase all three, which is fundas, which is all those videos, drill, which is checkpoint quiz, cat level, which is prep page. So in each class, we want to show you the concept and funda built slowly. We want to give some practice to consolidate basic ideas. We want to say, okay, what is the game in the actual exam as far as this topic is concerned? Fine. So the moment you finish a class, the way I think about it, you finish the class on, say, pipes and systems, you get a sense of, okay, these are my fundamentals. They're very clear. I know what I'm doing. I've got some practice. I know what cat level is. Right? Then you say, I think I need to do 20 more questions. I really don't understand. I'm not natural at writing 1 by m and 1 by n. M and n I'm comfortable with, but I'm never going to think about when I should think about rate, when I should think about number of days. I'm not a natural at that. Let me do this, more of this before I step here. Then revisit study material, the books, then go to speed test. You feel like, look, I got all fun days. I don't want to revisit fun days. I just want to kick on and improve my speed. Do speed test, then go to section test. You say, look, I've got all fun days. I've done 100 questions 3 months ago, 4 months ago. I get this topic. I just want to be game ready. Then go to cat level questions, which is part of the testing engine. And so everything in our question bank is cat level or tougher. So you can hit the question bank, which is there on the website, freely available, and hit any topic. There are 40, 50, 60 questions in each topic. So if you feel like you've covered all the basic ground and you just want to hit level out of 10 levels of difficulty, 8, 9, 10, and see where you stand for the real game, then question bank is a wonderful place to go to as well. A lot of times a particular concept becomes so frustrating that it just puts me off the preparation, where I get stuck in one thing. So there are multiple ways of doing it. Some people need to resolve before going to the next one. I am personally comfortable with just taking that one thing, putting it into a black box, pushing it aside, learning everything else, and then coming back to it. I like that because sometimes there are 10 chunks in a topic and I'm really stuck in the middle of point 4. I just keep it aside and say, look, I don't get it. And do 5, 6, 7, 8, 9. And then when I go to 4, it all falls in place naturally. So you need to give the mind a way of reordering that on its own. It usually happens. It frequently happens. So I put it in a box, set it aside, and then revisit after 4 days. The one thing that I completely did not understand on a Monday becomes a natural thing on Thursday. For a long time, NCR equal to NC n minus R. My teacher kept saying number of ways of selecting is same as number of ways of eliminating. Number of ways of selecting is same as number of ways of eliminating. I just didn't understand. I had no idea what I was eliminating. From 15 people, I had to select 4. Who am I eliminating? I didn't understand that phrase. Number of ways of selecting is same as number of ways of eliminating. So I didn't understand it for like a few weeks. And then I forgot about it. And then I revisited when the funda fell in place. Then it all fell in place. Number of ways of selecting 4 people is same as eliminating the remaining 11. I'm not selecting these. That's what eliminating means. So I'm selecting 4 or I'm not selecting 11. I'm kicking them out. So both are same. It is a very nice way of phrasing. Just that my mind refused to accept that idea of eliminating for a long time. So you let it go. Next time you revisit it, your mind is in a more natural place. It accepts the idea naturally, or you've learned something more where you're seeing it from a different point, or you sleep over it, you just come back to it. Very often so happens that if you're struggling for something from 7 p.m. to 8 p.m, we just chuck it away, sleep, next day morning it's just much clearer. And so it could happen like that. So my preference would be to set it aside and then carry on. Speed test book I would say speed test book and cat level and drill, about 50% are cat level, more than 50%, 65-70% are cat level, about 30% are merely for practice. So it's practice going up to cat level. Give it a read, we'll discuss this one. Simple enough question. I must tell you that we are discussing questions that students have posted. So these are not 2IM questions. And so questions that have been posted from somewhere. It's a doubt clarification session. We're taking the liberty of answering something. And so what is the area of shaded region in the figure given below? ABCD is a square and AB is 12. So this is 12, 12, 12, 12. DG is half of CD. This is A by 2. GF equal to FC. So A by 4. A by 4. AH equal to HE equal to EB. All three are equal. A by 3, A by 3, A by 3. So this is 4. This is 3. A is 12. So this shape GFEH is a trapezium. So you can plug in the area half into sum of parallel sides into height as a formula, or you can say I'm going to join this GE. So area of triangle GHE is half into base into height, half into 4 into 12. Area of triangle GFE is half into base into height, half into 3 into 12. Add these two, whatever the answer is, simplify that. So you can imagine that as a trapezium, or you can carve it into two triangles. The key point in both cases is the height is 12. Once you've got the numbers, remember that the height is 12, you're good to go. From each of the corners of a square sheet of side 10 centimeters, a right angle triangle was cut. The remaining sheet has a shape of a regular polygon. So a square of side 10. A right angle triangle was cut. This is a right angle. So I'm cutting off something like this, something like this, something like this, something like this. Pardon my diagram. The whole thing is 10. This should be A. This should be A. This should be A. Obviously, the diagram does not work the way I'm looking at it. It's a regular polygon of 8 sides. It's a regular octagon. And so this is A. This is A by root 2 because this is A. The right angle isosceles triangle. A by root 2. A by root 2. Area of a regular octagon. Now that I know it's an octagon, I'm going to draw a more reasonable looking octagon and then imagine that area very clearly. Fine. So let's join this, join this, join this, join this. And so this is A. So this is a square. And so this is A by root 2, 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 A by root 2. So I'm going to have A by root 2, A by root 2, A by root 2, A by root 2. Area of this right angle triangle is half into A by root 2 into A by root 2. Like that, I'm going to have 4. This into 4. And area of this rectangle is A into A by root 2. A into A by root 2. That's a rectangle here. Of these, we have 4. Plus A into A. This is what we have. Root 2 into root 2 is 2. 2 into 2 is 4. This whole thing goes away. 4 by root 2 is 2 root 2. So we have A square plus 2 root 2 A square plus A square. 2A square plus 2 root 2 A square. Fine. Now a plus root 2a equal to 10, or a is 10 by 1 plus root 2. 10 by root 2 plus 1 into root 2 minus 1 by root 2 minus 1. Root 2 plus 1 into root 2 minus 1 is 1. 10 into root 2 minus 1 is a. So a square into 2 plus 2 root 2, where a is 10 into root 2 minus 1. So it's 100 into root 2 minus 1 whole square, or 200 into root 2 minus 1 whole square into root 2 plus 1. Root 2 plus 1 into root 2 minus 1 is 1. So 200 into root 2 minus 1 square centimeters, which should be this. And I'm just going step by step so that we see the whole process. Obviously, you can cut some steps and gain some time, but I don't want to do this really quickly. I want to understand the whole process step by step. Whenever you carve out a regular hexagon, you get equilateral triangles. When you carve out a regular octagon, you get isosceles right angle triangles and squares and rectangles. So here, a regular hexagon, you're thinking about root 3 by 4 a square and root 3 by 2. Here, you're going to talk about all 1s and root 2s. A layer of hemispherical box. So I saw this question. So that's the base and the height. I did not get it. I'm unsure about this question. So those of you who are sent this question, I would love to see the answer. The number of hemispherical blocks that come out is not an integer. So I don't know whether you're leaving it out or you're slicing and dicing it, and how they have assumed that. So something seems funny about this question. So I'm worried about this. So I'm not going to discuss this. Fine. A good question. Give it a read. We'll discuss that. Once again, I'm not going to completely solve this. I'll give a starting point and an approach for this. Right, so let's do this. I'm going to draw this. There's a circle here. So there is, we want O, B, D, C, O. B, C, O. B, C. And C, D. This is 14, so this is also 14. This is D here. OB is 48. This is tangents. Quadrilateral OBDC is what we need to find the area. To start with, join OD. This is a kite. These two are radii. These two are tangents. So OD will be perpendicular to BC and will bisect BC. Not only that, OB is perpendicular to BD. Tangent perpendicular to radius. This is 14, this is 48, 7, 24, 25, OD equals 25. And area of this quadrilateral OBDC, and OBDC is area of this triangle plus area of this triangle. Into half into 48 into 14 into 2. That's all we need to find. You can find that. Suppose the question said find BC, then it's trickier. Even that can be done. This is the answer for this question. 48 into 14, whatever that 480 plus 192, whatever that number turns out to be. Suppose the question said find BC, then we'll use, let's say we say this point is P. OPB is a right angle triangle. BPD is also a right angle triangle. Call this as X. Call this as 50 minus X. Why 50 minus X? Half into Pythagoras theorem, 14, 48, 50, 7, 24, 25. So BP square, square root of 14 square minus 15 minus X square. Sorry, or 14 square minus 50 minus X square is same as 48 square minus X square. Solve that, find X and then simplify. If you have to find BP, PC, all of that. But area, far simpler. Pretty much covered everything. Been receiving a bunch of questions on the testing engine and on mocks. And so first up, Mocks will be releasing a set of 8 mocks. One is already live. We'll have a set of 8 mocks, and we'll have 4 mocks which are CAT 2017 slot 1 slot 2, CAT 2018 slot 1 slot 2. The first mock is freely available, so everybody can, it's already available. We'll load at the rate of 1 mock per week. So by end of August, we'll have all our mocks more or less live. At least 6 of the 8 mocks will be live by end of August. So 1 mock per week we'll have. Why do we have fewer mocks? Mocks are, we focus a lot on the solving and learning and analytical aspects of mocks, which is why we did not want to have a giant number of mocks. And so we insist that all students try to get from 2 providers. We're looking to do about 25 mocks. So 4 mocks are already available. Actual CATs serve as the best mocks. So 12 mocks you have access to. Get 12 more. Therefore, you have 2 providers giving mocks, about 25 mocks totally. That's a good number to go for. So review a mock aggressively and have a plan to hit about 25 mocks from now till exam minimum. 30 is fine, but beyond 40 it's just overkill. So plan well and try to hit about 25 mocks. 12 using the 2IM base. 4 actual mocks will serve as your best mocks, actual CATs. And then 8 from us. We specialize on the solution and learning and the strategy aspect. So spend time thinking about how you will plan your mocks, the 2IM mocks, but definitely get one more flavor. We've gone for quality over quantity when it comes to mocks. We don't want to dilute the quality of what we have to offer. We want to benchmark it as close to the real exam as possible with some variants to get you tuned to that. That's the idea. As far as the testing product is concerned, we already have it. We're running a couple of tests to make it app ready. We've gone for a separate analytics engine with big data, with a different type of charts thrown in. We will send you an email saying what analytics we're looking for. So we want to have an analytics setup which gives more than just charts, which can actually with insight tell you that, hey, your fundas are really strong here, but you need practice. Or your fundas are good and you're quick. Or you seem to be quick, but you're getting stuff wrong. So we want to benchmark accuracy and speed, both meaningfully tagged for each topic, so that it gives you insight. It tells you, hey, you need to work some more on this. You need to revisit fund days on this. You need to start from 0 on this, and you're actually the king of geometry. So we've spent a lot of time building that. So we will be releasing that product in maximum a week, 10 days. We'll outline how the analytics works, how the charts work. Any analytic is as good as the data it goes to. So it will take a while for your data to be meaningful. Don't interpret analytics after you have done 2 tests of 5 questions each. It will be meaningless. Once you have solved 800 questions, then analytics become meaningful. So solve first 500, 600 before you start looking at analytics. But the analytics engine that we have built is actually very useful, very insightful. We will give you an outline on how the analytics engine works. Take those. And all students of 2IM who have done the green course or the comprehensive course, whatever we add from here is automatically available to you on the platform free of cost. So please don't end up buying a DILR or a revision course or a test engine course or a mocks course on the platform. Whatever we add on the platform, we'll give you access for it till the exam, until your Jan 31st or Jan 30th or whatever the deadline is. Whatever layers we add, we have a plan to add about 6 to 7 more classes onto the platform. Revisiting some fundamentals, so that will get added automatically. We have a plan to reshoot about 10 to 12 or 12 to 14 classes again to add one more layer to them. That will also be available to you. We're adding an entire test engine of 4,000 questions, which will be live in about 10-12 days time, which you will have access to. Mocks, 8 of them, 2IM mocks and 4 actual CAT mocks, number 12, that will also be available. So all these are going to come on board. Mocks 1 per week starting this week. The questions test engine, 3,000 plus questions straight away, and another 1,000 in about 2-3 weeks time, starting from say July 20th or 21st. That will also be available. The new classes will just get added onto the platform. You just have to look at them, they will be there. So we will keep adding content from now till September. continuously, relentlessly. So we will have a final 2.5 months where we don't touch much on the platform and you have access to practice and crack. But we will relentlessly add content and stuff onto the platform from now. And for all 2IM students, all of this 2IM green or comprehensive student, all of this is available automatically. It'll just get added to your product. You won't have to do anything. You won't have to click subscribe, nothing. It'll be one more course icon there. You can click and start taking a test or the mock. So don't buy anything else. It is automatically available, free of cost. Fine. It was a wonderful session. I quite enjoyed solving questions. Hopefully it's been useful for you guys as well. We're good to go. Best wishes, because we're doing some new platform here. Our guys have come up with something new, so I'm going to struggle a little bit to sign off from this technology. But good session. Thank you. Best wishes for CAT. I don't know how to sign off. I'm going to put end stream. I hope I'm doing the right